So, very good morning to all. Today's lectures we are going to discuss about the problem solving. Okay. So far I have given the basic information about automobile gearbox, and this is the problem. It's a real time problem taken from a Maruti Suzuki Desire model. So let's read out the problem. Maruti Suzuki wants to design and develop a new gearbox for Desire model passenger car. The gearbox is manual transmission type with the constant mesh in all gears. The gearbox is to be used for 5 forward and 1 reverse speed. The first, second, third, fourth and fifth gear ratio are 3.545, 1.904, 1.233, 0.911 and 0.725 respectively. For the reverse gear ratio is 3.250 and the final drive ratio is 3.944. The maximum power is 74 horsepower at 4000 rpm and the maximum torque is 180 Newton meter at 2000 rpm. Design and analyze the gearbox starting from selecting a gear type, ray diagram, kinematic diagram and suitable materials for main and lathe shafts, bearing selection, lubrication, heat losses and gearbox casings as well. Consider the main and lathe shafts for the shaft design. Ignore the clutch and idler shafts for calculations. The tire specification is P185/70R14 88T. The GVW of the vehicle is 15.7 kilonewton and curb weight is 12.4 kilonewton. If any data is missing, take a suitable data for the design calculation. Very lengthy problem, right? It's complete gearbox design. Look at what information do we have here. So we have 5 forward speed, right? You can see this is the 5 forward speeds and 1 reverse speeds. The speeds given here 3 from here to up to this here. The reverse also is given, the final drive is given, and more importantly you have a 74 HP operating at 4000 rpm and 180 Newton meter at 2000 rpm. That gives N max and N minimum, and we need to do starting from no other information is given. So we have to do from gear type, ray diagram, okay, kinematic diagram and suitable module for main shaft, okay, bearing selection, lubrication, all those is given, okay. And one more important information is given, your tire specification and the total vehicle weight. GVW means gross vehicle weight, curb weight means generally the basic weight without any passengers, okay. That's the information is given, yeah. So we are going to approach the problem in different parts as we lectures move on. So first part 1, we are going to discuss about sawtooth profile. Sawtooth profile, that's one thing we are going to do, that diagram, sawtooth diagram, part 1. In part 2, it's a kinematic arrangement, kinematic diagram. Right. Here we are going to understand about the gear type also. What is the gear type? That information we are going to take it in part 2. In part 3, we will do the gear design. When you talk about gear design, we will talk about the module calculation, that is very important. the model calculation. That part we are going to do that in part 3. In part 4, shaft design, in part 5 talk about lubrication selection and bearing selections. And part 6 we will discuss about the gearbox losses, and case design as well. Okay. And when you talk about gear model, here we will talk about material selection. That is also part of the problem solving. Yeah, we will go one by one, part 1, part 2, part 3, part 4, so on. Okay, so tire specification given. If you look at the tire specification, this is the typical way of tire specification. Normally, you will have a number. You look at here. This is the number that will talk about what type of application. Okay, let's talk about what type of application. P stands for passenger. Then, and 215, you can see that this is 215. It's a nominal width of the tire in millimeter. Please see that only the tire will have the specification in different dimensions, and 65 is the ratio between the width, height to width. You can see that this is the height to width that's given, and R is the way the tires are arranged. It's a it's called a radial pattern or bias or ply. So these are the 3 ways how the tires are for a better friction aspect. And 15 is the rim diameter. Is talk about in inches. This is in inches. We have 3 dimensions. Very strangely, you have a millimeter, percentage, as well as inches. You have to find out all those information. Okay, and you can look at here. This P stands for passenger car, LT means light truck, and ST means special trailer, and T is temporary. So always will give the corresponding application. In fact, if you go even more further, you will see here. Okay, so this is your rim diameter. Yeah, this portion is your rim diameter, and this is the section height, and this is your section height. So if you want to know about the diameter of the wheel or diameter of the tire, that should be your rim diameter, right? I'll say R, rim diameter, plus 2 times what is it? Is the height, right? So 2 times height. So that is the one will gives about the tire specification. Okay, as I mentioned, look at this. The 145 is given width in millimeter, and the 70 is the ratio between the height by width, and construction radial or bias or else apply 3 way you can do that, and the rim diameter is inches, and this is about how much load can taken care, and this is a speed impulse. For us, this is important. What is these 3? This at least this information. This gives about the width. This is gives about width, and this is about the percentage height by width, and this is the rim diameter. Okay, in inches. Yeah. So can we calculate the tire diameter? So what is the problem is given? The specification of the tire diameter is given P 185 70 R, right, 1488 T. This is what is given. Okay. So as you are aware of that, so the 14 is the rim diameter. This is 14 is the rim diameter. DW we will say DR is a 14 inch, right. It is a 14 inch. If you equivalent to 14 into 25.4, you should get some value. So that should be how much? 259. Yeah. How much value getting? Is a 350? Is a 355.6? Is it how much value? 14 inch? Yeah, 355.6, right? Yeah, 355.6 millimeter. Okay. Then second dimension is given. This is the 70%. 70% means your height by width ratio is 70%. That's what it's meaning. Okay. What is this 185? W equal to 185 is the width in millimeter. 185 is in millimeter. Okay. So now we want to know h, right? We need to know h. So h equal to, right, 0.7. W value I know here, 185. 185. What is the value you are getting? 129.5 mm. Okay. So now I know the height, right, and also the rim diameter. So the diameter of the wheel or tire is equal to diameter of a rim plus 2 times the height. So which gives me 355.6 plus 2 times 129.5. So what is the diameter we are getting now? Yes. So are we getting 614.6? Right. 614.6 millimeter. Maybe we can round off for our easy understanding. We can round off to 615 millimeter. That is the dia. Okay. And of course, for our calculation, this is very important. In terms of diameter of the, in terms of radius, it should be how much? By 2, right? It will be 2. So 307.5 millimeter. That this is your diameter. Sorry, it should be radius. Yeah, it came out. This is fine. This is okay. Okay. Now we'll move on to the sawtooth diagram. Okay. So understand that sawtooth diagram we are supposed to have a, right, the vehicle speed in x axis, vehicle speed in kilometer per hour, and also in y axis it is in engine speed, right? Should be engine speed. I'll put E speed, and you need to know what is the N max, right, and N minimum. From there we will do the calculation. From there we will do the calculation. Yeah. So prior to the going to sawtooth diagram, so we know the power is given 74 HP, right? At what speed? N max 4000 RPM. Then the torque, maximum torque 190 Newton meter at N minimum, right? That's N minimum. How much is it? 2000 RPM. These are things. Okay. So in your calculation, which speed we should take? Is it a 4000 RPM or 2000 RPM? We should take the higher speed. Then only we know how much range for a first gear the vehicle can move, right? There is no point taking the minimum speed. So always better to use the higher speed for sawtooth diagram aspect. Okay. And also I want to give the recap. Your gear ratio Ig is nothing but, what is the Ig value? Your engine speed, ratio between engine speed and gear speed. Then final drive ratio is gear ratio by gear speed by wheel speed, then your overall drive ratio or else total drive ratio, both are same, overall or total drive, is IF into IG, that's give me NE by NW. Okay, NE by NW. Okay, fine. See, ultimately, I want to have a vehicle speed. I know it's easy for me. N max, N minimum is given the engine speed. I want to find out everything with respect to vehicle speed also in kilometer per hour. So, how are we going to do that? So, where we need to know V equal to R omega. I am sure you know this information. This V represent your vehicle speed, the vehicle speed. This R represent RW is your radius of tire. Okay, this information we already know. So, which is a 307.5 millimeter. This information also known to us. The omega is the speed of your engine. Omega is the speed of your engine. Right. This is information is given. Okay. I think this is very clear, right? So, you know N max 4000, N minimum 2000 RPM, and we know the RW is the diameter of tire is 307, and speed is going to be changeable. It is going to be changeable with respect to gear also. Okay, because already engine speed fixed. So, with the gear ratio only, the vehicle speed will change. So, we need to find out the engine speed and gear speed, with that how to get the vehicle speed. Yes.
Shouldn't omega be the angular velocity of the wheel? Because with the gears, the angular velocity of the engine and the angular velocity of the wheel are changing.
Yes.
Shouldn't the omega be the angular velocity of the wheel?
It is angular velocity, but where do you get it? Where you will getting?
We'll get it from engine, but it will.
Yeah. So, in fact, that is what I mean to say, that R omega, it's above the wheel. Okay. The what I am saying that it's a good question. The engine is move reciprocating, right? It's a linear motion. The linear motion converted into rotational motion by the wheel. So, the omega, in fact, it's a corresponding to the wheel rotation, angular velocity of rotation, but we are getting from the engine. That is why I mentioned as the engine speed. Okay. So, good observation. Yeah. That is the reason, in fact, we are taking from the gear ratio. Now, we will do one by one. So, I will have a tabular column. This is the gear, right? This is the gear ratio. Okay. And the total drive. Then I am talking about the speed. I am talking about the speed of the tire, NW speed, NW. Then finally, I need to know about the vehicle speed. The vehicle speed, kilometer per hour. Okay. So, this is the table, we are going to sort it out one by one. So, this is the first gear. What is the first gear value you are getting? 3.545. Yeah. Okay. 3.545. So, I know this is IG1, right? This is IG1 is 3.545. What is the IF? What is the value given IF? 3.944, right? 3.944. So, this is IO, total drive is IO is nothing but your IG into IF. If you multiply that, you should expect 13.981. 13.981. Okay. So again, IO can be written as a NE by NW, right? NE by NW. Okay. So I want to find out what is the W. I need to find out what is W. So NW equal to, right, NE by IO. This is the formula, we should use it. Remember, at the moment we are not considering the transmission efficiency. Sometimes the efficiency also will take into consideration. At the moment, whatever you are getting the input speed from engine, straight away we are taking. If the problem is given as efficiency 95%, that is also you have to include in this speed calculation. Okay. So what is the engine speed now? The engine speed is 4000 RPM. Am I right? Yeah. So already I know IO, right? I know IO. So 4000 by 13.981, that should give me 28.61. So this should be the speed. This should be the speed. Then I need to find out here itself. I will make it two. In fact, two aspect vehicle speed. One is with respect to meter per second as a linear speed v, with respect to kilometer per hour. Okay. Both ways I do that. Yeah. So what will be the speed here? I know NW is given. So I need to know V equal to RW into omega, right? Omega with respect to, as mentioned by the tire, right? Angular velocity of the tire. Okay. So R already know. So 0.3075 into omega equal to 2 into 2 into pi into, right. Then what is speed? 286.1 by 60. What is the value you are getting now? For that value, velocity please. Are you getting 9.213? Yes, 9.213. Okay. So now this is meter per second. If I want to make this a kilometer per hour, okay, simply you have to multiply. Kilometer per hour means 3600 per hour, then divided by 1000. That straight away I can multiply 18 by 5, right? If you do the complete exam, 18 by 5 to convert. V is in meter per second. Okay. If I want to as a V in kilometer per hour, I had to multiply 3600 divided by 1000. That give me V into 18 by 5. Okay. If you do that, you should expect 33.167 kilometer per hour. So this is the one. Now you know that I did for the first gear, and if you do for second gear, what is the speed ratio? 1.04. Okay, 1.04, and this should be 7.509, and this is 532.69. Then corresponding the vehicle velocity is 17.153 meter per second. By multiplying 18 by 5 for kilometer, it should be 61.75 kilometer. Okay. Similarly, if you do the calculation for third gear, 1.233, 4.863, 82.54 is your speed, tire speed, then the corresponding the velocity 26.486 meter per second, and then the vehicle speed would be 95.35 kilometer per hour. Then for fourth speed, okay, 0.725, sorry, it should be 0.911, 3.593, and vehicle speed 1111 sorry 113.28. Then the speed would be 35.85. The corresponding vehicle speed 129 kilometer, 129.05. Then the highest gear, fifth gear, it is 0.725. So the total drive 2.859. 1399.10 is the RPM. Then if it is 45.05 meter per second, then the highest speed for the highest gear 162.17 kilometer. So do we need to consider for the reverse speed? Not necessary, because we are constructing ray diagram for only the forward speeds. Reverse speed something is different, so not necessary. So always try to stick to the forward speeds alone. Okay. Now we know we have done the each gear aspect. You look at this. This is the gear and this gear ratio. As gear ratio decreases, your total drive also decreases, but the wheel speed increases, corresponding speed and the vehicle velocity increases. That you can able to see that. Okay. Now we have to construct a ray diagram. Now we got the information, because the ray diagram talks about the vehicle speed, right, and the engine speed. So both way we need to know that. Before proceeding, let me ask question. Is it what type of gear? Is it a progressive or geometric? Right, simple. So I have a 3.545, right, and if you take the next one 1.23, what is the value you are getting? Right, you will get you some value. Can I have the value, please? What is the value? 2 point? Okay, 2.87. If I do it for 1.33, the next gear 0.91, that should be 1.56, something like that. Yes, 1.56. So the step ratio is not constant. If you look at the step ratio between the adjacent gear is not constant. Obviously, if it is not constant, the gear will be logarithmic. Okay, it is logarithmic. Yeah, that's, please understand that. Now we will draw the sawtooth profile. So just take like this. This is vehicle speed. Kilometer per hour in this direction, and this is engine speed. Okay, in RPM it moves like that. So 1, 2, 3 and 4. So this is 1000 RPM, 2000 RPM, 3000 RPM and 4000 RPM. Okay. Then here 30 kilometer, 60, 90, 120, 150 and 180. Okay. And you know that this is your N max. This is your N max and this is your N minimum. Okay. This is your N minimum. So, what is the first gear says? What is my first gear operate? My first gear operate 33.167 kilometer. Am I right? That means when your vehicle is running at first gear, the speed can vary from starting from 0 kilometer to 33.16 kilometer. Okay. So, somewhere else the point will come here. That is one thing is there. Okay. Somewhere else will come, point will come. The next one is 67.75. So, some in this position, assuming that. Then third is a 95. This is the position. Then fourth 129. Okay. So, probably the 129 kilometer here. Then fifth is 162 somewhere else here. Okay. Just to draw the only the construction line. Just for understanding, this is another construction line for 60. Then another construction line . Okay. Now we got it. So, always you start from 0, right? Remember, whenever gear shifting, it should start from maximum to N minimum, right? So, this is the maximum. This is the maximum. This is the maximum. Okay. The next one should be this one. Spot. We got the maximum speeds. For each gear, we got the maximum speed. Remember, if the step ratio is constant, what happened to your minimum speed for each gear? Is it same or different? The step ratio is constant. If the step ratio is constant, it should start maximum and end with the minimum, irrespective of the gear shifting. Right? Then fuel consumption is more. So, if you use logarithmic, what happens? Your lower bound speed will be, gap will be reduced as increasing your speed, vehicle speed. See, suppose it to always passing through this point, supposed to be, right, but it is not. Look at this. This is the point is ends here. This, look at this is the maximum. The vehicle speed drop down to here for the second, right, and this is maximum. So, vehicle speed drop down to up to this position, and this is maximum and the vehicle speed is, and this is maximum and vehicle speed is. So, look at this. So, what is happening now? It is following logarithmic, right. In fact, your actual sawtooth will be up to this position, then moves here up to this position and moves here up to this position, then moves up and stop. Otherwise, it should come down to all the way, see here. This line should have been passed through corresponding this position. So, now look at this, what is happening. So, this is your N minimum. This is your N minimum. Okay. So, this is actually the sawtooth diagram for the Maruti Desire gearbox using progressive or logarithmic gears. It's not the geometric progression, but we are using logarithmic progression. That's the reason the step ratio changes. As step ratio changes, the gap between maximum speed, minimum speeds keep reducing. By doing that, you can save your fuel. Anyway, already I know that as if I move to the fourth gear, I know highest speed. Already speed is there. Why do you want to bring down the speed to 0? That's make unnecessary slow down the vehicle, but at the same time you are not saving any energy. The fuel still consuming. So to avoid that, I am look at this. What is the gap here between here to here is reducing. Okay. So this is one way to improve the fuel economy or specific fuel consumption. Okay. This is a sawtooth diagram for the vehicle. Now, next step would be we need to construct a ray diagram. Ray diagram is over. We need to construct kinematic diagram. Okay, we need to construct kinematic diagram. Before construction kinematic diagram, I will need to give this some information. So again, the transmission can be classified into single stage transmission and double stage transmission. The third is multi-stage transmission. You can see this information here. This is example for the single stage, two stage or double stage and multi-stage. Okay. And in case if you look at this, this is a single stage. Now how do you identify single stage? I have only one input shaft. You can see this, one input shaft, one output shaft. So these are the gears. Look at this. These are the gears. So input is coming and engaging, and the first gear here, second, third and fourth. Then corresponding meshing gear will give me the desired output. So this is type of arrangement is called single stage, and correspondingly you can look at this same. You have one input shaft, other output shaft. Okay. Yeah, this is the output. So here also this is 5 gears, but the only 2 shafts are there and the meshing and power transmission occur. Both are Volkswagen model. You can see that this is a Volkswagen model. I referred Automotive Transmission by Harold Neimer. This is an excellent book. And this is for single stage. And look at this double stage. Okay, this is the double stage. You have input shaft input here. This is from your clutch. Then you have a speed reduction. Straight away, look at this. The speed reduction is happening, and this is your lay shaft. This is your lay shaft. Then you have a corresponding gears which is meshing here. First, second, third, and fourth. Then finally will come output comes here. So this arrangement is called double stage. In fact, this is the arrangement we are going to use it. Not only that, this is exactly replicating your riveted gear train. Remember, the input and output are in the same path, right? Collinear path. That's what you can see that. And this is again this 2-stage 4-speed gearbox get track. This is you can see that. And interestingly, here also CG means counter shaft. Okay, it's a counter gear. They say that. Yeah, we can use the same as a clutch gear. This is your input. Okay, the power transmission gear reduction is happening, and this is your lay shaft. This is your lay shaft. From here, the output goes in this direction to the other aspects. Here also, we have first, second, third, and fourth. Interestingly, the fifth gear is directly connect with your input shaft. Okay. Again, you have how many shafts are there? 1. This is 1 shaft, second shaft, and three shafts. Here also 1, 2, and 3. So if the shafts are more than 2, that's one that observation. The second observation, input and output are in the same path, linear path, collinear thing. That is also there. and more importantly placing the gears. You can place different way. In this diagram, observe it, the first gear from the right. As you move right to left, the gear ratio changing first, second, third and fourth. That arrangement also you can do that. If not, look at these gears. Okay, this side figure B on the right hand side. You can place it from right, you can place it from the left and move to the right. Left to right, okay, or right, and you can have a right to left. Either way you can do that. Of course, whichever way you do, you have to make sure that the dynamics of masses need to be balanced. Okay, dynamic of masses, that means the rotating gears need to be balanced. Yeah, and again we have another combination. This is called multi-stage. So multi-stage usually used where your center distance even smaller. Interestingly, look at here. This is your input shaft. IS means input shaft. One input shaft is common to two output shafts. You can see this is the output shaft 1, OS1, and this is output shaft 2. Okay. Again, if we have more gears, instead of 5 gears, if you have 6 gears, 7 gears, 8 gears, with the limited space, then this kind of arrangement can be considered. Look at the lower gears, you can see first and second, and higher gears are one shaft, and another middle gears are another shaft. Okay, but they have to have a same input shaft. And one more thing is, if you look at carefully, this is from the input shaft, right? This is from the input shaft. The same gear meshing for fourth gear in the output shaft 2 and sixth gear in output shaft 1. Such a way that you have to design. There are gears are available. I mean, this gear type of gears are available in automobile section. This is adopted in get track, and if you look at on the right side, again you will have input shaft 1, okay, input shaft, and output shaft 1, okay, OP1 and OP2, right. Here also you can see here in this arrangement, the first 4 gears are in the output shaft 1, the highest speeds are in the output shaft 2, okay. But the common gear meshing for the 5th gear in output shaft will also mesh for the 4th gear in output shaft 1. Similarly, if you look at for 6th gear, right, this I think here is not necessary. So here is you have separate gear, but there is a one more gear is you can see that the third is meshing with this gear is meshing with for third aspect. Okay, only one common gear is meshing in this arrangement, whereas here your two common gears meshing for the output shaft 1 and 2. So this arrangement also can be considered for your gearbox design. Again, depends on your place arrangement, how much sentences can have it. Okay. In fact, what I want to say that before designing the vehicle, right, they will fix the engine size. They will fix the engine size, engine dimension. So based on the engine size and engine dimension, we have to design the gearbox. It's not other way around. Design the gearbox, then go for the size, engine size and vehicle size. No, you fix the size. So what is whether you want to 7 passenger seat or 9 passenger seat or 5 passenger seat, based on that, or SUV type, you decide first. Then for that application, choose the engine. With that, you have to go for a gear design. Okay. So I think I'll stop now. So next class, I've given the information. Using this information, we are going to construct kinematic diagram for for Maruti Desire gearbox. Okay, thank you.